All right, this is going to be a recap of the 2018 free response question number 2 for the AB Calculus exam. We're given a particle moves along the x-axis with a velocity function of, for time, 0 to 3.5. So the first thing I'm going to do is, this is a question 2, so it's a calculator. So I'm going to go ahead and enter that function into my calculator there in y1. Okay, so go ahead and type that in. And then we're given the particle is at position x equals -5 at time t equals 0. This is an initial value. We're going to need that at some point. Right, question A says find the acceleration of the particle at time t equals 3. So question A is asking you to find a of 3, a being my acceleration function. A of 3 is simply equal to v prime of 3, because acceleration is the derivative of velocity. So now I'm just going to go to my home screen, and I'm going to type in math option 8, which is derivative. Okay, so we're going to go d dx, and our function is in y1, so it's alpha f4 y1. If you have the TI-83 old style, it'd be vars, y vars, and then I think it's enter, but it's y1. And then over here, instead of putting x, we're going to go ahead and put our value, which is 3. And we do that, and we get negative 2.1181. So negative 2.118 would be our final answer. Part B, find the position of the particle at time t equals 3. All right, so position is going to be an antiderivative, which we're not going to be able to do the antiderivative of this by hand. Okay, so we're going to need the fundamental theorem of calculus part 1. It's find the position of the particle at time t equals 3. So we need this point, and we have this point. Okay, so we're going to integrate from 0 to 3 v of t dt, and that is equal to, okay, this is the fundamental theorem of calculus part 1 where that comes in. Go ahead and pull that out of our foldable again really quick, but that's right here. Okay, and that's f of b minus f of a equals the integral from a to b of f prime of x dx. Okay, so this is going to be x of 3 minus x of 0. Okay, and that's our position. That is what we're trying to find. We're trying to find the position at time t equals 3. We know this, and we can use our calculator to get this. So the first thing I'm going to do is I'm going to use my calculator. Well, I can do this. I'm going to move this to the other side first. This is just algebra. So it's going to be x sub 0 plus the integral from 0 to 3 v of t dt equals x of 3. We know x of 0 is -5, and then we just go ahead and evaluate this in our calculator. So it's going to be math, and now we're option 9. We're integrating from 0 to 3, and the same thing, it's what we have in y1, so we don't have to retype it, dx. And we end up with 3.2397. Doesn't matter. You want to write at least 3 decimals there. I tend to write a bunch, but in the end, I'm just going to add that to -5 in my calculator, and I get negative 1.7602. So the position at time t equals 3 is negative 1.760. All right, question C says evaluate the integral from 0 to 3.5 v of t dt, and evaluate the integral 0 to 3.5 absolute value of v of t dt. Interpret the meaning. So we're just going to go ahead and do those both really quick. Integrate from 0 to 3.5 v of t dt, and integrate from 0 to 3.5 absolute value of v of t dt. Okay, recall one of these is going to be total distance traveled, and one of these is going to be net distance traveled. The one without the absolute value bars is net distance traveled, or your displacement. Okay, that's how far you will be from the initial position or where you started from. Okay, this one is going to be the total distance traveled. You're going to make all those negative distances positive. It'll be how far you traveled in total. Okay, but either way, they're both calculator problems. So it's math option 9, 0 to 3.5. And then let's just go y1 on this one, dx. And we get a value of 2.8439. You can either say 3 or 4 here. Okay, you can round it up to 4, or you can just call it 843. I'm going to call it 844. And then I'm just going to write what this means, and this is net distance, also known as displacement, and then I'm going to say over the time interval 0 to 3.5. And same thing on the next one, math option 9, 0 to 3.5. But this time we need the absolute value bars. Those are under math, arrow over to number, option 1. And then from there, same thing. We're going to put in our y1, arrow out here and get dx. And we end up with a total distance traveled of, wait for it, drum roll, 3.737. And that's total distance traveled over the time frame 0 to 3.5. All right, our last one, a second particle moves along the x-axis with position given by x2 of t equals t squared minus t for t is between 0 and 3.5. At what time are the two particles moving with the same velocity? Okay, really that's just when the velocity of the first one, which we have the velocity function, is equal to the velocity of this one, and this is the position function right here. Okay, that's a position function. Okay, so it's really going to be the velocity, original function v of t, is equal to x2 prime of t. Okay, so what I did was I went ahead into my y equals and I graphed the derivative of t squared minus t, or in this case x squared minus x, at x. Okay, I just went ahead and graphed it. And so, and then my window is going to be from 0 to 4. You could go 0 to 3.5. You might have to play with your y's a little bit, but I went with that. And I hit graph here, and I ended up with these two graphs. Okay, so one of these is the velocity function. One of these is v of t. The other one is the derivative of x2 of t. Okay, but I just want to know when they are equal, and they're equal when they intersect, and they intersect right here. And I want to know that time. The question asks, at what time are the two particles moving with the same velocity? So I'm just going to go find the intersection there. So it's second calc, option 5. First curve is v of t. Second curve is the derivative of x2 of t. The guess, my curve is pretty close, and there's only one intersection in our window anyway. Go ahead and hit enter. And I get a value of, can't see it there, let's focus in on that a little bit, 1.5705 or 1.571. So we're just going to write t equals 1.571 is our time. I will post the rubric that goes along with this so you can see the point values. And now you know the solutions, and the videos for the for numbers 1, 3, and 4 will be posted as well. Those will be coming from my wife. I hope you've enjoyed. Hope everybody's doing well, and have a great weekend.